Today's lesson is going to be on the unit circle and special right triangles. We're going to start an exploration that will be finished in class. We learned last class that we can define the trigonometric functions on a coordinate plane. This allows us to extend the definition beyond the first quadrant and allows us to be able to graph all different types of angles, even those larger than 360. We learned that sine of theta is y over r, and the reciprocal of sine is cosecant, and that is r over y. Cosine of theta is x over r, and its reciprocal is secant theta, which is r over x. Tangent theta is y over x, and its reciprocal, cotangent, is x over y. Today we're going to look at what happens when these definitions are put on a unit circle. In a unit circle, the radius of the circle is 1. Previously, the radius could be anything, but now we're going to look at what happens when it's 1. Below are the ratios that come from your special right triangles that you learned in geometry. We're going to look at each of these ratios, first at 30 degrees, then 45, and then 60, using the definitions that you learned last class. So the sine of 30. If you look at, here's our 30-degree angle. The x-coordinate is root 3 over 2, and the y-coordinate is 1/2, and since we're on the unit circle, the radius is 1. So sine is y over r. So when we take our y-coordinate, which is 1/2, and we put it over the radius, which is 1, we discover that the sine of 30 is just 1/2. Cosecant is the reciprocal of sine. So if we take 1/2 and we just do its reciprocal, the cosecant is 2 over 1, which is just 2. Cosine, as we learned, is x over r. So the cosine of 30, x is root 3 over 2, so we can say root 3 over 2 divided by 1. When we divide anything by 1, it's just the numerator, so cosine of 30 is root 3 over 2. Secant is the reciprocal of cosine, so we take the root 3 over 2 and we reciprocate it, so we're going to flip-flop it. So we have 2 over root 3, which we need to rationalize, so root 3 over root 3. So the secant of 30 is 2 root 3 over 3. Now tangent of 30. Tangent, we discover, is y over x. So our y-coordinate in this case is 1/2. Our x-coordinate is root 3 over 2. So now we actually have to do some math. So we have 1/2 divided by root 3 over 2. We're going to keep our first fraction, flip our second one, 2 over root 3. And then we can cancel our root 3's, our 2's, not our root 3's. We have 1 over root 3. When we rationalize this, I'm going to multiply by root 3 over root 3. We end up with the tangent of 30 being root 3 over 3. Oh, that's a little ugly. Try writing that again. Root 3 over 3. Now, we know that cotangent is a reciprocal, so we can do x over y, or we can take the tangent and reciprocate. I'm going to go back to this version of the tangent, which is going to be the easiest to just take the reciprocal of, because it will just be root 3 over 1. So the cotangent of 30 degrees is root 3 over 1. Now what I'd like you to do is pause the video and do exactly what I just did with 45 degrees and with 60 degrees, and then unpause it, and I will show you those answers. You can see after going through this whole process what the specific ratios are for sine, cosecant, cosine, secant, tangent, and cotangent of 45. You can also see the same thing for sine, cosecant, cosine, secant, tangent, and cotangent of 60 degrees. Now we're going to look at what the general definition of trigonometric functions are on the unit circle. We have our x, our y, and our 1, and we have our theta. Well, if you think about this, Sine of theta is y over r. Well, if r is just 1, it's y over 1. So the sine of theta on the unit circle is just y. Cosecant, which is the reciprocal side, is just going to be 1 over y. Cosine of x we know is x over r. Well, r is just 1, so if you have cosine of theta is x over r, and r is 1, cosine of theta is just x over 1, or just x. The secant, which is the reciprocal of cosine, is just 1 over x. And then tangent, because tangent and cotangent are unrelated to the radius, whether you have it on the unit circle or any size circle, is always y over x. And cotangent of theta is always x over y. Now, one of the reasons why we use the unit circle is it allows us to have what are called quadrangles. Those are the angles at the quadrant, at the 4 quadrants. So this angle right here, which is pi over 2, or 90 degrees, you have the coordinate is 0, 1, which means the sine of pi over 2 is in fact just 1, because sine is y, and the y coordinate at that quadrangle is 1. You can't do this with right triangle trigonometry, which is why it's important to put sine, cosine, and tangent all on the coordinate plane. Today we're going to be looking at all the special angles that we've learned, the 30, the 45, and the 60s in all the quadrants. We started that above, but we're going to look at some of the patterns that happen. Now, one of the things we need to talk about before we do that are reference angles. Reference angles become very important when finding angles on a unit circle. The special reference angles are extremely important. A reference angle is defined as an acute angle formed where the terminal side of theta is the x-axis. So if here is your original angle, red would be the original angle right here, but the reference angle would be here. So if the original angle was 120 degrees, the reference angle is the angle that's the distance between the x-axis and the terminal side. So in this case, it's 60 degrees. The reference angle would be 60 degrees. What we have found is that the reference angles for the special angles in radians are really easy, really helpful when doing them. We're going to explore them in just a second. This is the activity on the very first day we explored trigonometry. You can see all the 30-degree reference angles if you highlight them in yellow, because they are 30 degrees away from the x-axis. So this is 30 degrees, this is 30 degrees, this is 30 degrees, and this is 30 degrees. Notice that all the 30-degree reference angles have a denominator in radians that's over 6. So all of the 30-degree reference angles are pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. For 45-degree reference angles, you can see right here, here are all the 45. I can't draw very well. 45-degree reference angles. Let's try that again. Here's all the 45-degree reference angles. Notice that 45 all have the denominator of 4. So the 45-degree reference angles are pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. The last set of reference angles are the 60-degree reference angles. Here are the 60-degree reference angles. Notice how the 60-degree reference angles all have 3 as their denominator for radians. Pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. This will be very important in our exploration that we're about to do, because we'll discover that angles with the same reference angle will have the exact same xy coordinate. The only difference will be the sine of those coordinates. We discovered when we explored the unit circle that the x-coordinate on a unit circle is the cosine of the angle, and the y-coordinate is in fact the sine theta of the angle. Those are the actual coordinates on the unit circle. We're going to explore what happens with each of the reference angles. In the video, we're going to explore 30 degrees, but the rest of this activity you're going to do in class, exploring the different angles beyond 30. So in the 30-degree family, we remember from our 30, 60, 90 triangles that this length, which is the x-coordinate, is the longer side, and it is root 3 over 2. Root 3 over 2. The y-coordinate in a 30-degree angle is the shorter side, and it's 1/2. So our long side is root 3 over 2, and our shorter side is 1/2. Okay? In a 30-degree angle, the long side is our x-coordinate, and the short side is our y-coordinate. So if we look at the 30-degree family, we can look at the coordinate here. This coordinate is our long, followed by our short. So our long is root 3 over 2, and our short is 1/2. That is true over here, except in the second quadrant, our long side is negative, so it's negative root 3 over 2, and our short side is positive 1/2. Now, down here, we have our long side, which is negative root 3 over 2, and our short y, which is negative 1/2. We can fill out the rest of the coordinates with our last coordinate down here, where our x-coordinate is root 3 over 2, which is our long side, and our y-coordinate, which is short, is negative 1/2. We can now look at what all of this actually means in terms of the 30-degree family. Now, we learned at the beginning of this lesson that anything over 6 is part of the 30-degree family. So the nice thing about anything with the same reference angle is if we use that denominator of 6, we can put pi as 6 pi over 6 and 0 and 2 pi as 12 pi over 6. Now, we can fill in all the reference angles. So the first one is pi over 6. Now, if we start at 6 pi over 6, 1 less than 6 pi over 6 is 5 pi over 6, which happens to be the 30-degree reference angle in the second quadrant. 1 more than 6 pi over 6 is 7 pi over 6, which happens to be the 30-degree reference angle in the third quadrant. In the fourth quadrant, it's 11 pi over 6 because that is 1 less than 12 pi over 6. Now, what does all of this mean? Well, we can find the sine, tangent, and cosine, and secant and cosecant and of all of the angles in our unit circle using these ideas. I'm going to do the sine of 5 pi over 6 and then explain it to you all. Well, the sine of 5 pi over 6, now we recall that sine is y. Well, we know that the y value in the second quadrant, which is where 5 pi over 6 is the short value, so the sine is 1/2. Now the cosine of 5 pi over 6, cosine is the x value. The x value in the second quadrant is negative, and it's long. So the cosine of 5 pi over 6 is negative root 3 over 2. Now the tangent, we're going to do the tangent of 11 pi over 6. Now remember, tangent is y over x. So in the fourth quadrant, the y value is negative 1/2, and the x value is root 3 over 2. So if you do negative 1/2 over root 3 over 2, then you do the division. Remember how you keep your original fraction, you flip your second one. When you simplify it, you get negative 1 over root 3. Once you rationalize, you get root 3 over 3, which means that the tangent of 11 pi over 6 is negative root 3 over 3.